So we are doing 1.4 using limits to find tangents. So some of this stuff you know from before, but I will briefly go through it. If we take a look at this graph that I've drawn at the top here, this stuff in green, if we look at this a value, then it makes sense that up here this would be f of a. That's all old stuff, we know that. If I have x here, then we know that that would be f of x over here that I'm pointing at. And then this blue stuff here, the difference between the two, we can define as change in x. All stuff that we know? So if we take a look over here, it's saying the change of x will go to 0 as x approaches a. That's kind of just stating the obvious when you look at it, right? But I wanted to show it on a graph so that we could use that to then understand this formula that we have in the box here. So going through this stuff that I'm underlining here, this is old news. This is the stuff we've been looking at or talking about. So m, or the slope, is the limit as the change in x approaches 0 when we have change in y over change in x. We know that as the slope formula from way back in grade 10 and on and on. Good? So I guess the only new part, and this is the reason that I wanted to go through this, is it's set equal to, this is the new part here. So it's again, same old thing, new or slightly new perspective or new way of looking at it. The limit as x approaches a, so that's the same thing as what's going on over here in the blue, for f of x minus f of a over x minus a. Do you see this also is sort of repeating stuff that we already know? It's just basically talking about it in terms of these values here, but it's still indicating slope. So that's all good so far? Okay, so using this, let's determine the slope of the tangent line at a equals 3 for this function f of x equals x squared plus 1. So I do truly feel like I say this every single class, but I'm not teaching anything new today. And hopefully, if the more I repeat it and the more I take that approach, you're going to believe me and it's going to feel like, why are we doing this? I already know this. And that's when you know you understand the stuff. So let's do a lot of the same old stuff. Taking a look at, again, this part here, if that's what we're interested in, then I want to figure out what f of a is. So this is just a matter of like number crunching and plugging things into our formula. So for my first step, I'm going to take this and I'm going to say I want to know what f of 3 is, because I know in my little formula or for slope I need to figure that out. So basically I just need to figure out the y value, right? So we do that by taking our equation. We would have 3 squared plus 1 from our equation that's given to us here. So we know that f of 3 is just equal to 10. So I'm going to circle that because we're going to need it. And then when we take a look at this formula, if I'm trying to figure out slope from this using this new but not so new approach to it, we want as x approaches 3, because our a value was at 3, so the only new part is now we're talking slope in terms of limit, but in the past you just did the y2 minus y1, blah, blah, blah. But do you see that it's actually the same thing? Good. That's the key to getting this stuff and understanding. If you get that it's the same old stuff, you're going to find it easy and it's going to make sense. So when we go to do this, it says for f of x, so I'm going to plug in this x squared plus 1 minus my f of a here. Oh, you know what I should be doing? I should be color coding this. I'm losing my touch. X squared plus 1, and then minus my f of a, which is what we just calculated, which is the 10 here. And then that whole thing would be over x minus a. So that's actually just x minus, and our a value was 3. So truly, we are just plugging in the numbers into the formula. Good? And then this is why we learn all this stuff. We apply all the tools and the stuff that we've learned over the years. So I would simplify at the top. I would see that I get x squared, and I have 1 minus 10, so it's going to be minus 9. And at the bottom, we have x minus 3. And at this point, I just can't color code anymore. Are we good? Okay. And then you'll notice this pattern, how it magically works out to numbers that are so nice and easy for us to work with, because what happens at the top? It's a difference of squares, so we can factor that to make it x plus 3, x minus 3, and at the bottom we had an x minus 3, so you see what I mean about how it perfectly, idealistically all works out. So after all of that, what we're dealing with is the limit as x approaches 3 for x plus 3, because that's all I had left right here after we simplified everything. And we know if we plug that in, if I just take that 3 and plug it in here, after all that work, I just get 6. Good? Now, when we are going through this in class, I go through every single little step and show you, like, no, you don't have to do that. I'm doing it so that it's super clear where everything's coming from. Good? But don't just write the number 6 and give that as an answer, right? So do show a little bit of where you're getting stuff from, but I don't need every single nitpicky detail. Are there any questions before we move on? So do you believe me yet that we're kind of just doing the same old stuff all year long? All year long for the next 9 weeks. Here's the next one. Find the equation of the tangent line for x equals 2 for the function f of x equals 2x squared plus 5x plus 1. Yeah. Yeah, of course. Just for the sake of consistency, I'm going to take the same approach as in the last question. So let's start by looking at this and saying that our a value is going to be 2. So again, we're sort of shifting to look at what a is in terms of our equation. So I pick that out, and I know that I need to find what f of 2 is then. So I'm always consistently doing that as my first step, because that gives me the value that I need for my y value. So in here, I'm just going to plug in a 2 wherever there was an x. So I'd have 2 times 2 squared plus 5 times 2 plus 1. And so that it's super clear, what I'm saying is where there was an x there, that's where I've plugged in this 2 here, and that's where we're getting our values from. When we go and do all of that, we find that it's equal to 19. So I'm going to circle that because we're going to need it. I really truly do feel like so much of math is organization. The number of times I see students and myself, if I'm working quickly through stuff and I don't stay organized, you just like leave off a negative or you leave something behind. So take the extra like 2 seconds that it takes to circle the stuff or to use the whatever works for you. I find a lot of times it's not even that people don't know how to do the math, it's they've forgotten something or left something behind. So this is where we again do the same thing as what we were doing before. So we're looking for the limit as x is approaching 2. So again, we're getting that from up here. For our f of x, which was this whole thing here, so I'm going to write that, 2x squared plus 5x plus 1. And then I'm going to subtract from it the value that we just found, which was that 19 that we circled up here. So again, if we just look at this as the same old repetitive pattern, we find the y value using the a value and plug it in and do, like, it's really just the same old thing over and over again. And then at the bottom, we would have x minus 2. And now this takes us back to like why you learned all the things along the way in pre-calculus and math 10 and 9 and all the rest. And that is, we want to simplify this. So the first step to doing that is just our like terms here, which are just those. So we have 2x squared plus 5x. And here we have minus 18. And the whole thing is over x minus 2. I'm running out of room, so I'm just going to carry on down here. And we're kind of in the same boat or same position as last time, where clearly at the top we have a trinomial, so we usually go to factoring. So we want to factor this out, and we find, again, magically, that it works out so perfectly because we had an x minus 2 at the bottom. And then when I factor, remember the factoring, we're going to multiply your a and your c value together. You're looking for two numbers that multiply to negative 36, add up to 5, and then go through and fill that in, and that's how we get these factors. Or there's different methods of factoring. Stick to the one that you know best. But this is what it factors out to, and we're again in a similar position as last time where we can cancel things out top to bottom, which is so perfect because look at the limit was approaching 2, which would have caused us a problem. But it's no longer an issue because, I'm going to go in this direction, the limit as x approaches 2, well now I'm just left with 2x plus 9 to figure that out. So almost always you're going to end up in these perfect idealistic scenarios where the top and the bottom cancels and you don't need. So if that's not happening, go back and double check your work that you didn't do something wrong. And because in most scenarios, that's why you've done all this stuff over the years of factoring and working with fractions and all of that stuff are tools to simplify and shrink things down. So then we would simply plug this in. And when we plug it in, we would just end up getting 4 plus 9. So after all that work, this just ends up being 13, which just to be super clear, actually, let me write it down here. We found the slope using this. Again, to be clear, because it's easy to get lost in the calculations and forget, like, what is that I just found? Make sense? And you're probably thinking, like, what? Why would I do this to find slope? This feels way harder, way more work than the stuff that you learned in the past. And again, it's to understand this concept of limits, which is then going to lead us into derivatives. Good? Which is why I'm eager to get it out of the way. So, are there questions about that? So far, it feels like review? Good? Alternate notation. So here's another way of looking at it. And again, I'm going to give you a minute because I know this is a lot of stuff. And I'm going to say it's up to you if you want to. Like, I only drew the graphs so that it's clear to you where the stuff is coming from. But you really just need, well, this part we already did. It's pretty much, do you see it's a repeat of what we just finished? I just wanted you to compare it, or to have it there to compare with the new one, which is the one on the right. So you don't have to draw the one on the left. It's just for me to show you the comparison. So choose whatever makes sense to you. I feel like you can't read this. This says behaves. if you are finished and waiting for other people, have a look at it and see if you can understand it and look at that comparison and get it on your own. Maybe we don't need to go through much of an explanation if it makes sense. And if not, of course, I will explain it. Okay, so do you see that it's pretty much exactly the same thing as what's on the left, except now we have this gap here, or the change in x that we were looking at before, we're calling it h. It's the same thing that's happening. We're calling it h, so instead of having an x over here, we now have a plus h. Otherwise, everything else is exactly the same. Do we get that? Okay, so this though is pretty significant or important. You will see it come up. It says in this version, h behaves like change in x, that's what I just said, and we let it decrease as small as possible. So that's that change in x approaching 0. In this case, it's h is approaching a. Good? Okay, so find the slope of the tangent line for x equals 2 on this function. And this time we're just basically practicing the new notation. I'm going to run through it with you. I would normally give you time, but I'm going to run through it with you. I'll give you a minute to copy down this question, and then I'll go through it with you. Okay, so I was going to try to show, well, can you guys see that okay? If I leave it at that height? Okay, I just want to be able to also show you the equation while we're doing this. But basically, in order to find this, we would do the limit as h approaches 0. So we're, again, looking up here. For f of a plus h, so do you see in this case the a value is this 2 here? So we would do f of 2 plus h. Minus, it says f of a here, so again, the a value is that 2. So minus f of 2. And the whole thing would be over h. So that's the initial setup. Just like what we did in the last examples, we want to take this part and we want to actually figure out what f of 2 would be by plugging it into the function. So I'm going to do 2 times in here, it's going to be 2 squared plus 5 times 2 plus 1. Good? So we're simply plugging it into our original function here. And again, I'm pretty sure I just used the same equation as in the last one, right? So it's just, we know already, or we can look at it by plugging in the 2, but we get 19. So it's good to sort of, like, depending on the function, you may not need to actually write it out and do the work. You might be able to just do it in your head. But do figure out what that is. And again, I think a lot of times this comes down to organization. And then the rest of it, we simply go through it. The limit as h approaches 0 for 2. Okay, let me explain this part. You know how, okay, let me show it this way. You know how this says f of 2 plus h? Going back to when you first learned about function notation and plugging things in, you did this stuff last year in Pre-Calc 12 as well. What that means is wherever you see an x in this equation, we're going to plug in 2 plus h. So, what's the best way for me to show that? Like this? 2 plus h, like with the blue? Does that work for everybody? And then plus 5, and in brackets, instead of x, I'm going to have 2 plus h. I feel like my color coding just went, oh, I don't know what's happening. I'm hoping it's working to show you the concept. Is it working? So I basically took this whole equation, and wherever I had an x, I took that 2 plus h and plugged it in. But I kept everything else the same so far. And then at the end, I need to do minus f of 2, which is the minus 19 at the end. And the whole thing is over h. Again, I am going through this with like little baby steps and going through every single little thing. I wouldn't expect you to do this. But if you know yourself and you know that you do have a habit of like leaving off a negative or forgetting something, then go ahead and write all the steps out. Do whatever you need to keep organized and to keep track of things, because can you see that there's a lot of stuff to keep track of here? That's the biggest part with this stuff. So I am going to assume that you all know how to do this. Are you okay with me? Like, we would have to expand this out. 2 plus h times 2 plus h, right? Can I skip ahead and just tell you what we get with that? Everybody okay with that? And I can trust that you can go back and if you want to practice and figure out how we got it. Oh boy, I'm really getting lazy. I don't want to keep writing this over and over again, so I'm just going to do that. And we'll write it at the end. But we would get 8 plus 8h plus 2h squared plus 10 plus 5h plus 1 minus 19. When we go through and expand all this out, like when we expand that out, we FOIL that out and then distribute the 2. This is what we end up with, all over h. And again, you should start to see a pattern where we're able to get rid of the h. So if that's not quite happening, then you probably want to go back and double check your work. But if we take a look at this here, and we want to figure out what we're able to simplify, well, there's only one 2h squared, so I still have that. But I can start to cancel out some of the other stuff. So if I look at 8h and this 5h, I have a plus 13h, so those are gone. And again, that's, maybe I should color code these. That's my way of keeping track of like terms. And then we have 8 plus 10 plus 1 minus 19. How convenient, it all cancels out, so we don't even need to worry about that. And then we have the h at the bottom. And I was being lazy and just rewriting this, but it is actually the limit as h, or sorry, not rewriting this. So I will rewrite it now, and we know that there's a problem if there's an h at the bottom, but the good news is you also can see at the top, we can factor out an h. So I have 2h plus 13, and then my h's end up canceling here. Those are gone. So now if I do the limit as h approaches 0 and all I have is 2h plus 13, now it's not, there's no issue because I don't have an h in the denominator. It's just going to be, that's going to be wiped out when I plug in a 0. So my answer after all that work, actually maybe I should also say it's that m is equal to 13 because that's what we were doing this for. There is your assignment.